13 through 24 of this exam. Here we go. Basic trigonometry question. Make sure you have your calculators ready. Number 13. In the diagram of triangle RST below, the measure of angle T is 90 degrees. And the length of RS is 65, ST is 60. What is the measure of angle S to the nearest degree? So this is a classic SOHCAHTOA question. Sine, cosine, tangent. Okay? So let's go ahead and try it. So in order to solve for the measure of angle S, we need to figure out, well, what sides are we given? We're given the side next to it, and the side next to it is called your adjacent side. Adjacent means next to in geometry or in math. Okay? And this 65 is your hypotenuse, because remember, the hypotenuse is always located across from your right angle because it is the longest side of that triangle. So if we're using an A and an H, we're looking at these little guys here. Are we using sine, cosine, or tangent? We're using the AH. We're using cosine. So what I'm going to say is we're going to take the cosine of angle S is equal to, well, the adjacent side is 60, and the hypotenuse is 65. I just put it into that basic trigonometric ratio. Now, we go to our calculator. We need to solve for the angle measure. So what that means in geometry is that we actually need to take the inverse cosine of 60 over 65. You always use inverse sine, cosine, or tangent if you're solving for an angle. So whatever that answer comes out to, we got it. So press trig. By the way, I use a TI Inspire. Pretty cool calculator. You could find the link on my website to buy it. I suggest you do. The cosine inverse of 60 over 65. Make sure your calculator is in degree mode, by the way, and you get 22.6. So we get 22.6. Rounded to the nearest degree, you get 23 degrees. 5 or more up the score, 4 or less, let it rest. 0.6 rounds it up to 23 degrees. Your answer is choice 1.
All right, number 15. Line segment RW has endpoints R, which is -4,5, and W, which is 620. Point P is on line segment RW, such that RP is in a ratio with PW, and the ratio is 2 to 3. What are the coordinates of point P? Okay, anytime we've seen questions like this in class, we've always taught you guys to graph these endpoints using graph paper, and we want to break up the segment by using parts. So if I know that the ratio is 2 to 3, when I add that together, it's really telling me that that segment is being broken up into 5 parts. Okay, so if you guys look on Canvas, we have attached a document for graph paper. So if you can print that, that's great. If you already have graph paper at home, that's awesome. And if not, just do the best you can as you follow this question. All right, so I already went ahead and I graphed that line segment RW. Let me move this down just a smidge so I can see that R has the coordinates -4,5, and I know that W has the coordinates +6, +20. All right, you're gonna have to create your own graph. I suggest starting somewhere in the middle because again, that Y point of 20 is kind of high. You're gonna need a longer Y axis for this question. All right, so now that I've graphed both of those points, the first step is to find the slope. So slope is rise over run. So if I count, I can see that the slope would be up 15, and then it would be to the right 10. All right, I already went ahead and counted that in advance. So I'm just gonna go back to my original paper and I'm gonna write that down. So again, the first step is to find the slope of line segment RW, and that slope was 15 over 10. It was rise over run. All right, and then we had gone over with you guys that now you want to take your slope and you want to divide it by how many parts you have. So if I have 5 parts, I'm going to divide the slope by the number 5. All right, so 15 divided by 5 is 3, and I know that 10 divided by 5 is 2. So this is the new slope that I want to apply to my graph on the next page. So I'm gonna just, before I move back, go over with you. It's telling me that I'm moving from R to P and then from P to W. All right, this is super important. I know that R is where I want to start, so I'm gonna just label that real quick. And I know that W is where I'm going to end up. Okay, so when I start plotting this new slope of 3 over 2, I know that I want to start at R and move my way towards W. So again, I'm going to rise 3 and run 2 and plot that point. Then I'm going to do it again, up 3 over 2, plot it, up 3 over 2, plot it, and then again up 3 over 2 and plot it. All right, because that last point would have been W. And then again, if I look back, it says that I want that ratio from R to P to have 2, and I want that ratio from P to W to have 3 parts. So now I'm going to go back and I'm just going to highlight that out. So from R to P, that should have 2 parts. And I know that from P to W should have 3 parts. And I can see that. So I know that this point right here has to be point P. And now I just have to decide what the coordinates are. Well, if I look at my graph, it looks like I don't have to go left or right. So my X value is 0. And then I have to rise 11. So P is going to be the value 0, 11. Now, if I go back and I look at my question, I can see that 0, 11 is choice 2. So that would have been my answer for number 15.
Anything is fine. Number 16. The pyramid shown below has a square base, a height of 7, and a volume of 84. What is the length of one side of its base? So you need to know that the volume of a pyramid is 1/3 capital B times the height. And if you don't know it, it is on your reference sheet. Now, what you need to know is what in the world does that capital B stand for? Well, the capital B stands for, and they don't tell you this on the reference sheet, I wish they did. Capital B stands for the area of the base. Okay? Well, the base in this case is a square. So what is the area of a square? Well, the area of a square is just length times width. Know it. So what we're going to do is we're going to plug in the information that they gave us. The volume is 84. The height is 7. So 84 is equal to 1/3. We don't have capital B. We have 7, though. Okay? So we get 84 is equal to 7 times 1/3 is just 7/3 times the capital B. Oops. 7/3 times the capital B. To isolate the B by itself, we're going to multiply by the reciprocal of 7/3. So the reciprocal is just 3/7. Multiplied by 3/7 on both sides. Okay? Now what we need to do is just take 3/7, type it into our calculator, 3/7, multiply by that by 84, we get 36. So capital B is equal to 36. But wait a minute, folks. Is that 36 there? Yeah, it is. That is not the answer. Why? Because that is the area of the base. We don't know what the sides are, so we're going to call those X. The area of the square in this case is actually X times X, which is X squared. So what we need to do is set these equal to each other. X squared equals 36. Take the square root of both sides. One of the lengths is 6. 6 right there. So that's your answer, choice 1. They're asking you for the length of one of the sides of its base, not both. All right, so that's why it's going to be choice 1. Moving on to number 17. Okay, this one again, just like a couple questions ago, I think it was question number 10, you got to do a lot of work to solve for this angle. In the diagram below of triangle MNO, the measure of angle M and the measure of angle O are bisected by MS and OR respectively. Segments MS and OR intersect at T, and the measure of angle N is equal to 40 degrees. If the measure of angle TMR is 28, the measure of angle OTS is what? So they say bisected. So that means that the measure of angle M is bisected here, and angle O is bisected up here. And it says that this is 40, and they just told us that the measure of angle TMR is 28 degrees. Find the measure of angle OTS, which is over here. We're trying to solve for that angle. So if this is 28 degrees, we know that this angle next to it is 28 degrees because they just told us it was being bisected. Okay? So you need to use a little bit of a keen eye here. Look at this. Look at the whole picture, the whole triangle. We already have two angles, ladies and gentlemen. We have this angle and we have this angle. We have to solve for this. All we need to do is just take 180 degrees minus the 28, minus the 28 again, because there's two of them, minus the 40 degrees. The top angle that you see there, folks, that angle is going to be a measure of 84 degrees. Okay, so this whole angle is 84 degrees. Well, again, though, it's being bisected. So what is each angle? Well, you just need to take 84 and divide that by 2. You get an answer of 42 degrees. Okay, so each angle is 42 degrees. Perfect. Now your goal is to solve for that pink angle that you see here. Well, how do we get to that? Well, let me erase some of this stuff just to have a cleaner image, and let me show you what's going on. We know that this angle is 28. I just told you that this is 42. We're trying to solve for this angle. This is 42 as well. Well, there's another triangle here, folks. Look at this triangle. That could help us because a triangle has 180 degrees. To solve for the angle next to the pink angle that we're trying to find, we take 180 degrees minus the 28 degrees minus the 42 degrees. That gives us an angle measure of 110 degrees. So this angle that you see here is 110 degrees. Well, apply the next theorem that you know. Linear pairs are supplementary. This is a linear pair, which equals 180 degrees. So you just take a straight line, which is 180 degrees, minus the 110, and that gives you an answer of 70 degrees. That is going to be choice 4 for that question. Tedious, but doable. Number 18. Oh, dear. Okay. In the diagram below, right triangle ABC has legs whose lengths are 4 and 6. If you didn't read this question, you might have got it wrong. What is the volume of the three-dimensional object? People just read it and stopped there. Read on. Formed by continuously rotating the right triangle about side AB. Oh, those nasty sneaks. Unbelievable. This that you see here, that AB, it just said rotated about side AB. Folks, that's your height. Not this. This is actually the base. Or, sorry, not the base, the radius. That's the radius. This is the height. You had to read that question. And by the way, if it's saying find the volume of the three-dimensional figure, if you don't know by now that if you rotate a right triangle about one of its legs and it forms a cone, you're sleeping. Make sure that you know it's a cone. So the volume of a cone is 1/3 pi r squared times height. Again, you can get that right from your reference sheet. Volume equals 1/3 pi. The radius is 4 squared, and the height, oh shoot, hold on one second. Trying to get, there we go. The height is 6. Let's type that into our calculator. Leaving pi out of the equation because all the answers are in terms of pi. So I'm just going to type in the numbers, the constants. 1/3, even though the pi is really a constant, but that doesn't matter. 1/3 times 4 squared times 6, we get 32. So your answer is 32, and then just smack on the pi afterwards. Your answer is choice 1. If you found out, or if you thought that CA was the height, you probably got choice 2 and you would have gotten it wrong. It's not 48 pi, it's 32 pi.
Okay, number 19. It says, what is an equation of a line that is perpendicular to the line whose equation is 2y equals 3x minus 10, and it passes through the point -6, 1. I want to start off by just going over what's important and able to solve this question. So if it says, what's the equation of a line, I'm just going to highlight that. And I know that the equation of a line is y equals mx plus b. All right, so that's the formula that I should be thinking of. And I know that perpendicular is a key word as well. If I want a line that's going to be perpendicular with something else, I know that that's telling me that the slopes need to be negative reciprocals of each other. All right. So if I look at the equation that they gave me, that 2y equals 3x minus 10, right off the bat, it is not in the form of y equals mx plus b. All right, so my first step is going to be rewriting that equation. And then I'm going to divide everything by 2 so I can create that y equals mx plus b that I need. All right, so when I divide, I get y equals positive 3 over 2x minus 5. And now this is important because I have the slope that I need of the line that they gave me. All right, but I don't want this line. I want to find a perpendicular line. So I'm going to take this slope of 3 over 2 and I'm going to make it a negative reciprocal, right? Because I want those lines to be perpendicular. So instead of writing positive 3 over 2, I'm going to change it to negative 2 over 3. All right, so that's really the slope that I need if I want to solve this question. So again, I know the equation of a line is y equals mx plus b. And now I'm going to plug in all of the key information that I have. So I know that the point that they gave me was negative 6, 1. So I know negative 6 is my x, positive 1 is my y. And again, I also have that slope, which is the negative 2 over 3. All right, so I'm just going to plug all of that in and start solving. So my y value is positive 1. So I have 1 equals, my slope, that m value, is negative 2 over 3 for my perpendicular line. And then my x value, well, the x was negative 6. So I'm just going to use parentheses when I plug that in. And then the b value is what I'm solving for right now. It's the only variable that I don't know. All right, so I simplify this. I get 1 equals. When you multiply this out in the calculator, you get the number 4. And then I have plus b. Now I want to get b by itself, so I have to move that positive 4 by making it a negative 4. So if I subtract 4 on both sides, well, 1 minus 4 is negative 3, and I know that's going to equal my value of b. And then I'm just going to take this and I can plug it into the equation so that I can get my final answer. So again, y equals negative 2 over 3x, because that's the slope that I needed, and then that b value was minus 3. So I have y equals mx plus b, and it looks like choice 2 is going to be my final answer.
All right, here we go. Number 20, parallelogram. All right, stuff. In quadrilateral blue, shown below, BE is congruent to UL. Which information would be sufficient to prove quadrilateral blue is a parallelogram? Okay, well, this isn't that bad if you know your parallelogram properties. To prove a parallelogram, I'm actually just going to tell you the one thing that they're asking you for. There's many ways to prove a parallelogram. You could prove both pairs of sides are two pairs of parallel sides are present. You could prove two pairs of opposite sides are congruent. You could prove the diagonals are perpendicular. They bisect each other. You could prove all this other stuff. But the one thing that they want you to know is, do you know that just one pair of congruent and parallel sides proves a parallelogram? Did you know that? You should. So basically, if we're saying that BE is congruent to UL, we're really looking for BE is parallel to UL, because if these are congruent, we're looking for the parallel answer. These make no sense over here. I just know it. BE is parallel to LU. That's going to be choice 2 for that question. All right, almost done with the multiple choice. Here we go. 21. A ladder 20 feet long leans against a building, forming an angle of 71 degrees with the level ground. To the nearest foot, how high up the wall of the building does the ladder touch the building? Okay, so a ladder 20 feet long leans against a building. Okay, there's my ladder, there's my building, here's my level ground. So this is 71 degrees. This is a 20-foot ladder, and it's asking you how high up the wall. So it's saying find this, the height of the wall. Okay? So, again, this is a classic SOHCAHTOA question. This is your reference angle. We need to find the opposite side. And this is our hypotenuse. We're given that. So if we're using O and H, we're using sine. So we have the sine of 71 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 20. From here, we just cross multiply. So we get 20 sine of 71 equals x. Type that into your calculator, 20 sine of 71. Make sure your calculator is in degree mode, 20 sine of 71. And that gives you 18.9. 18.9, which is the nearest foot. Your answer is 19, choice 4. All right, folks. The next question is,
All right, number 23. A fabricator is hired to make a 27-foot-long solid metal railing for the stairs at the local library. The railing is modeled by the diagram below. The railing is 2.5 inches high and 2.5 inches wide, and is comprised of a rectangular prism and a half cylinder. How much metal to the nearest cubic inch will the railing contain? Okay, this is a hefty question. It looks way trickier than it is. You just have to really pay attention to the information they're giving you, or else you can easily get the wrong answer. So as I'm reading through, the first thing I want to do is just look at the actual question. It says, how much metal to the nearest cubic inch? So I'm going to underline that. And the giveaway here is that they're telling me they want cubic inches. Anytime I see the word cubic, I should immediately be thinking volume. All right, so I know this is going to be a volume question. All the volume formulas that you would need for this Regents are located on the last page for the reference sheet. All right, so now if I look back at the actual question, I can see that they're giving me, again, that key information is 27-foot long railing. I know that the railing is 2.5 inches high, 2.5 inches wide. And I can see that there's two shapes here that make up the railing. The first shape is a rectangular prism, so I'm gonna highlight that in yellow, and then I'm actually gonna highlight the rectangular prism itself in yellow as well, just so it's clear for me to see what's happening. And then the other shape is a half cylinder. So again, I'm going to highlight that maybe in blue, and then I'm going to go ahead and just highlight that half cylinder in blue. Again, I'm a very visual learner. I feel like that helps. All right. The issue I'm seeing here right off the bat is that these units do not match. And I know when we were going over this unit in class, we had made a huge point to bring that up, that it's easy to get this answer wrong if you don't carefully look at those units. So I have to read the question. Do I want the nearest cubic foot or the nearest cubic inch? It says cubic inches. So I want inches. So I'm going to keep this 2.5 and I'm going to keep this 2.5. But that 27 has to go because it's in feet. So now I have to think to myself, well, if I want inches, I know that there's 12 inches in 1 foot. All right, so since I have to move from feet to inches, well, feet to inches, I can see that that number is getting bigger, 1 to 12. So I know I have to multiply by 12 to make this conversion. So I'm going to do 27 times 12, and I get the number 324. So I know 27 feet is really 324 inches, and that is the number I want to use to solve this question. So right away, I'm going to get rid of the 27 on my diagram, and I'm going to change it to 324 inches because that's the number I need. All right. Again, if I know that I'm solving for volume, I'm going to maybe go to the last page of my reference sheet and look up, what is the volume of a prism? What is the volume of a cylinder? You know, and write those formulas down. So when I flip to the back, I can see that the formula to find the volume of a prism is capital B times H. And again, when I flip to the back, I don't see the formula for a half cylinder. I see it just for a cylinder. So I'm going to start off by writing that down. I know that a cylinder has a volume formula of pi r squared h. But again, that would be for the entire thing, and I only want half of it. So what am I going to do with this formula? I'm going to half it. I'm going to divide by 2. All right, and now I'm just going to go back to the question, start plugging in so I can answer. All right, so if I want to find how much metal the entire railing is going to contain, that I know if these two shapes make up the railing, eventually I'm going to add those together to get my final answer. All right, so I'm just going to set myself up here with the prism. So I know that capital B stands for the area of the base. So if I look, the base of the prism is a rectangle. All right, so how do I find the volume? How do I find the area of a rectangle? Well, the area of a rectangle is length times width. So that capital B is really L times W. And then the H just comes down for the ride. All right, so I know eventually I'm going to do length times width times height if I want to find the volume of the prism. So now I have to look back at my diagram. Well, I know the prism is highlighted in yellow. So I can see here that the length is 2.5. So I'm going to plug that in. And if I look at the width, this is where they try to get you, boys and girls, because they're telling you that the base of the railing to the top of the railing is 2.5. And you don't want that value because you only want to the yellow, which is right in the middle, okay? I'm going to explain when we get to the cylinder how I know this is halfway, but it is. All right, so what's half of 2.5? Well, when I cut that in half, I get 1.25. So that's really just the height from the 2.5 at the base to the height here of just my cylinder, it's 1.25. All right, so I'm going to include that as my width. And then I can see the height from one side of my prism to the other. That height is 324. So that's going to be the last value that I plug in. All right, when I multiply all three together, I end up getting the number 1012.5. All right, it's exact. It goes right to 0.5. There was no other values to write down. Okay, now I'm going to look at the cylinder. So if I look at my half cylinder, I know that's in blue here. So if I want to plug in for my half cylinder formula, that's going to be pi r squared times h divided by 2. All right, so I have to first see what my radius is. Well, if I look, they're telling me that if this base is 2.5 inches, I can elevator that segment up, and I know that this base for my cylinder is also 2.5 inches. But I don't want the entire line segment. That would be a diameter. I only want half of it. That would be my radius. And it just so happens that we already found half of 2.5 before. It was 1.25. So I know that my radius halfway would be 1.25. All right, so I can plug that in over here. That's how I knew, boys and girls, before that I was going to take this width, which was originally, it looked like 2.5, and I was going to cut it in half. Because I know if this is a cylinder, if I go up, left, down, or to the right, that would be a radius. It would have to be the same all the way around. And then if I look over here for the height, again, how do I get from one half circle all the way to the other? Well, I can see that the height, again, was 324. So I'm going to plug that in. All right, if you guys had your calculators at home, or if you have that Calculator X app or a website that you use, you would type all of this in, and when you do, you would get a nice big decimal. It's 795.215640 ... All right, I can't round because this is not my final answer. Now I want to go ahead and I'm going to take the volume of the prism. I'm going to take the volume of my half cylinder, and I know I want to add those together because I want to find the volume of the entire railing. All right, when I add those together, I get 1,807.7. And when I reread the question, it says I want to round to the nearest cubic inch. So I have to stop right here. When I look at the neighbor, it tells me to round up, so it's going to be 1808, which would be choice 3.